Welcome, class, to Moments with Meyer. Today, we are going to be talking about trig identities and proving trig identities using the identities. How many times can we say identity? Using the identities that we got last section in 5.1. Okay. All right, to be honest, here we go. We are starting, because yesterday we did number 1. This is going to be starting with number 2. And actually, I think number 2 is probably going to be the most difficult out of all of them. And we're going to start with the more difficult side. That's what we talked about with the strategies from yesterday. I've got 2 fractions that are being added together. What should I be looking for first? And what is the common denominator?
1 plus sine 1 minus.
Perfect. So 1 plus sine x times 1 minus sine x. And in order to get the common denominator of 1 plus sine x times 1 minus sine x with this fraction, what do I have to multiply both numerator and denominator by?
1 minus sine.
So 1 minus sine x over 1 minus sine x gets multiplied by this first fraction to create the common denominator of 1 minus sine x, 1 plus sine x. Okay. Key component right there. And actually, I'm writing a bit big. There's quite a few steps on here. And so what do I need to multiply this second fraction by? I'm going to multiply both numerator and denominator by 1 plus sine x. And so therefore, I will get a common denominator like what we said of 1 minus sine x, 1 plus sine x, or 1 plus 1 minus, however you want to look at that. All right, so in the numerator then, I'm going to distribute. I get cosine x minus sine x times cosine x. I just multiplied the cosine by 1 and cosine times negative sine x plus, same thing over here, cosine x plus cosine x times sine x, or sine x times cosine x. It doesn't matter the order because it's being multiplied. All over my common denominator of 1 plus sine x, 1 minus sine x. And again, I'm wondering, does it equal 2 secant x? Or do we have fake identities going on here? How many cosines on this numerator do I have? 2. Oh, I've got a sine x cosine x that's negative and a sine x cosine x over here that's positive. These can cancel. Why can they cancel? Because these are being multiplied together. Sine and cosine are being multiplied together. And over here, sine and cosine are being multiplied together. They're identical. Mrs. Meyer flip-flopped them as I wrote them. But 2 times 3 is the same thing as 3 times 2. So when it's being multiplied, the order doesn't matter. But this one's negative, that one's positive, so those can cancel out. So I'm just left with 2 cosine x. Now, I'm going to go ahead and multiply this out because the way it's written really isn't going to help me much with 2 cosine on the top. So I get 1 times 1 is 1. 1 times positive sine x is positive sine x. And 1 times negative sine x is negative sine x. Those cancel. Minus sine squared x. Does it really equal? Okay, so I come up here and I get 2 over, what is 1 minus sine squared x?
Cosine squared x.
Cosine squared x. Does it equal? Does it equal the 2 secant x? So this cancels and I'm left with 2 over cosine x, which is 2 over cosine, and 1 over cosine is secant, so 2 over cosine is 2 secant x. Does equal 2 secant x. It does check. So the main piece to pull out of this is the common denominator that we need to find, and that is we see that over and over and over again. Evan, put your phone away. We see that over and over and over again. We need a common denominator. And so with that common denominator, we have to, whatever fraction it is that we multiply by, we're going to create that. And that's just basically multiplying this fraction by 1, multiplying this fraction by 1 as well, creating that common denominator. Okay, any questions on number 2? All right, moving on to number 3, unless you want to stop me. You know, looking at which side do I want to play around with, the one on the right, sine plus cosine squared, really doesn't get me anywhere. If it was sine squared, possibly. So I might do something over here on the left-hand side. And what do we see? Do you guys see anything that might work to start off with? Factor or distribute. All right, I think that's a great first step. So we could take cosine times tangent. We get cosine x times tangent x. And then cosine times sine times cotangent is cosine times sine times cotangent x. Does it equal sine x plus cosine squared? That's the question we all want to know. Now what do you think I should do? I love that. Put it in terms of sine and cosine. So cosine x, I'm actually going to put it over 1 since tangent and cotangent are fractions themselves. So it becomes sine x over cosine x. Cosine x over 1 times sine x over 1 times cosine x over sine x. Now granted, I've done this a couple times, so knowing cotangent and tangent real quickly, but you are welcome to be pulling out your identity sheet on that to double check that. Now please notice that I do have a plus sign, but what's going on to the left of the plus sign? Those two fractions are being multiplied together, so therefore I can cancel things. What's going on to the right-hand side of the plus sign are also being multiplied, so I can still cancel. I cannot cancel something from the left with something from the right because of that plus sign. Does that make sense? Okay. So I'm left with sine x plus, oh my gosh, look at that. Wow, that was pretty. And I'm finished. Bet you didn't see that one coming. I don't, yeah, I forgot a plus sign here. All right, questions on number 3. All right, number 4. Okay, number 4. Now wait a minute. Look at this. Tangent squared minus sine squared is the same thing as tangent squared times sine squared?
No way.
4 minus 2 is the same thing as 4 times 2? I don't think so. But let's see if it's different with trig. All right. Here we go. Tangent squared minus sine squared. First step. Is this an identity here? No, it's not. Well, heck, let's just do what we were told. Let's convert to sine and cosine. So let's do sine squared over cosine squared. Let's see where it takes us. Now, I could write that over 1, but what am I going to need this sine squared to be? A common denominator of? So if I put it over cosine squared, what do I have to do to the top? Multiply it by cosine squared. All right, so now I'm just going to rewrite it with the common denominator because I really don't know where I'm going yet. Actually, that's a lie. I see it and I'm so excited, but I'm going to pretend that I don't see it. I have a what? Sine squared x minus sine squared x times cosine squared x. What do I get to do? Anybody see what I can do?
Can you cancel out the cosines? No, you can't.
Why can I not cancel these?
Need a subtraction.
Because it doesn't make a heart.
Yeah, it doesn't make it hard.
We don't love it. That was really kind of good.
The sine squareds don't cancel.
Why do the sine squareds not cancel?
Subtraction.
Because one's multiplied by cosine. Oh, wow. This is awesome. So what else can we do? Those are great. That's exactly right. The canceling's not happening. Take out a sign. Find the common factor. Woohoo! Okay, sine squared and sine squared. All right, so that's my common factor. Now, once I pull out a sine squared, it's a matter of like division. So I'm going to take sine squared divided by sine squared, leaves me with 1. And I'm left with cosine squared. Oh my gosh, you guys see it? Okay, what is 1 minus cosine squared?
Sine squared.
But I'm going to write it like this. Because one of our suggestions of strategies is to learn how to pronounce it, but to know where you're always headed. That's a good life lesson. Have a goal. See? See?
Why didn't you put a negative 1? Because you said sine squared minus sine squared. If you take out a sine squared, it's going to be negative.
Well, there's the negative right there. This sine squared is divided by this sine squared. That's a positive 1. This over here, the negative is right there.
I don't see it.
So here, what is sine squared over cosine squared?
What is sine squared over? That's insane.
Isn't that just something? Because the tricky part there was thinking that this was sine to the 4th over cosine squared, which you could do. But knowing we are going to tangent squared and sine squared, keeping it as sine squared and sine squared would be the best strategy there. So that's why it's always important to know where you're headed. Where are you going? Okay? Did you guys get this cleared up on where the 1 minus cosine squared came from? And okay. Do you see how I can factor out a sine squared and a sine squared? Okay.
We were thinking the negative sign still goes with like the sign.
I don't see a negative sign. Right here?
Yeah.
Okay, that negative then is down here. I'll show you. Sine squared divided by sine squared is what? 1. Sine squared divided by sine squared. So if I have, can you see me? See that? Sine squares cancel, correct? And I'm left with negative cosine squared.
I get it now.
Okay. Okay. All right, number 5. Cosine to the 4th minus sine to the 4th is the same thing as cosine squared minus sine squared. Says who? Okay, what I want you to think of with this is this right here. And see if you can figure that out. This has to be the difference of perfect squares, just like what Eddie said. And this is a times a gives me a squared. B times b gives me the b squared. So knowing that, can I do this? Multiply that out in your head and see if you get to that. I do. Cosine squared times cosine squared is cosine to the fourth. Positive cosine sine squared, negative cosine sine squared, cancel. But negative sine squared times positive sine squared gives me my negative sine to the fourth. What is cosine squared plus sine squared?
1.
Look at that. Does that just totally make your day or what? Check.